Hello there, PreCalc. It's been a while, but we'll be back into the rhythm of having these videos in the evening. So let's start. We're going to study another case, a special case of the law of sines. And when we're looking at the law of sines, there's one situation that can be quite aggravating. So we'll tackle it tonight. It's called the ambiguous case. Ambiguous means there could be more than one solution. It's not really clear. So it's sort of the unclear case. Perhaps you think a lot of my teaching is the ambiguous case. Well, this one actually earns the title. So let's go and look at this ambiguous case, and I hope that you find that it is unambiguous. All right, what happens here is we saw some uses of the law of sine today, and the ones that we saw today had two sides and an angle, or two angles and a side, in this type of form: angle, angle, side, or side, angle, side, or angle, side, angle. And today we're going to, or tonight, we're going to look at this case. These work out just fine, and we were doing those today just fine. And now we're looking at the case where it is two sides and the angle in this direction. Here the two sides are known and the angle in between them, we call that the included side angle. And here we knew two angles and the side opposite one of those angles. Here we knew two angles and the side included between the two angles. Here we know two sides and an angle that is not between those two sides. And you can tell it's going to be trouble from the very beginning, because look at what it says backwards. So that will help you remember that this is not a clear case. We can't even say that word. So, but it does show up. This case does show up. And let me jump in and tell you what to do when this is known. So if I sketch it in general, remember we're doing SSA. We know two sides, so let me call the triangle A and B and C. But I'm only going to sketch in here what we know. So we know one side, so I'll call that side B, because it's across from angle B, lowercase b. And we know the another side, and I'll put it up here. That's going to be side A. And then we also know the angle, which is not in between, so I'll put it down here. So we know angle A. This is known, so I'll put a little mark there to indicate. So I'm drawing in what we know. And notice I didn't connect this side A down to this side, because I'm not quite sure if it does connect, because I haven't been given enough information to tell. I don't know this angle, so it could be over here, over here. I could swing it any direction I want, and because it's unknown. So I'm not sure of the angle. So this is just a pure speculation here. I just stuck it here. And I don't know the length of this side. Remember, let me circle what we know. We know this, we know this, and we know this. We do know the length, but we don't know the angle. And this is set in stone. So this is like cemented, because of this angle is known. So therefore, this is set in stone, this is set in stone, because this angle is known. So imagine these are cemented in place. This and this are cemented in place. But we don't know how long this is. We just know that it's cemented in this direction. And this, we do know its length, but we don't know its angle. So it could be anywhere swinging around this point there. So that's a guess. So to determine if we even have a triangle, like I drew a situation here where it doesn't even make a triangle, which shortens your work. So we're going to compare it to the height of the triangle. I mentioned this kind of formula today in another context, so you're familiar with hearing about it. But when we are in trig class, we prefer to work with right triangles. So I dropped I dropped the line straight down from vertex C to this side, and I made a right angle there. So now I have a right triangle, and I'm much more comfortable. I can breathe easily. And I notice that the sine of angle A, being this angle, is opposite over hypotenuse. H over B. And we use that, as I said earlier, today or yesterday, depending when you're viewing this. So this holds a lot of information for us because I can solve that for H by multiplying both sides by B, side B, and I get that. So observe that. It tells us in here are the secrets of how many answers. How many answers are there to this particular ambiguous case? How many answers? All right, so I can look at the problem and I can see what side A is. This is in theory, so you'll actually have a number, and you will compare that number to this value H. So if this value H and A are the same, then this side will swing over here and be exactly a right triangle. And we will have one answer. So let's take a note on that. If A equals H, if this side, and we'll know because it will be given to us originally, it was given, the circled things were given. If A equals H, then we have a right triangle and there's only one solution. And we can get the parts quickly with Pythagorean theorem. So we'd be really happy if that was the case. However, it might not work that way. Maybe at side A is less than angle H. Then side, I'm sorry, not angle. Side A is less than length of height H. So if that's the case, we have a situation where this side here does not, it's less than this. No matter what angle I put it, I can swing it all around. I can put it here and here and here and here. I can swing it all the way around this point. And it will never meet this side and make a triangle. So then your work is even quicker. There's no solution. But then, what if if I keep saying angle, I'm sorry. If side A is between, let's say side A is between, well, we'll do this one. Suppose A is greater than B. Now wait a minute, we were working with H. How come B came out to play? Because that's another situation. So let me actually put in a side B. I said down here A is greater than B. And so, or equal to. Let's see if I have a push pin on my desk here. All right, I'm going to pin that in there. So say this is side A. It's obviously exaggerated. It's way bigger than B. And remember, we don't know this angle, so I can swing it around, put it where I want to make a triangle. So if this is side A, look how much longer it is than B. And if I swing it around, I can't make a triangle when it's over here or here because this side is cemented at this angle. So it's not going to make a triangle here because it goes out of the picture, it's so long. But if I move it way over here, look, we don't know how long this side is. So as long as we keep that angle, we can extend this side all the way over to meet that and make a triangle. But that's the only triangle possible. So let me go down here. If A is greater than or equal to B, there's still one solution. And last case, and this is the case that is going to be our focus. If the height is less than side A, which is less than side B, let's talk about that. See if I can even snip that really short to try to show you. Let me get some scissors. Alright, so this is side H, and that's going to be less than side A. Our string is side A. So here's H, and we want this string to be less than H, but, I'm sorry, H is less than A, so we want this one to be greater than H, but less than that. So that's kind of a hard thing for me to guesstimate. It's got to be greater than H but less than B. So I'll try this. I have some technical difficulties here. Like sawing through my string. Let's see if I was able to recreate that. All right. So here we have it. H is less than A, would you agree? Here's H. A is my string, so H is less than A, but A is less than B. Not quite. Almost there. Let me do another surgical rendition here. Let me remove it here. I'll cut it off the other end. It'd be nice if I just had a piece of string. Could I find any string? No. All right, so now I have this situation. So I have H is less than A. So as you can see here, this length, I'll pull it down a little. All right, this length here, A, is greater than H. And then over here, if I swing it over here, I can see that B peeks out and A is less than B. So how many solutions can there be this time? Well, I can swing it this way and make a triangle by ending the side right there, or I can swing it this way and end the triangle right there. All right, so I'm going to remove this apparatus, and I could make a triangle this way or this way. So I have this little triangle here, or I have this big triangle here, bigger triangle here. So in this case, I have two solutions. All right, so that sets up the theory. And so I'm going to take the rest of tonight to show you how to do these kind. So here's the gist of my information, and we'll go from there. See you on part 2.